In today's class and video, we are going to look at the extraction of plant pigments. And we will start our introduction by looking at a very important glassware used in the extraction process. And this is the separation funnel, and this is the picture of the separation funnel. And what you have to note is that a separation funnel is a laboratory glassware used for separating immiscible liquid. And the principle by which this glassware works in the extraction process is that immiscible liquids separate out in layers depending on their densities in a separation funnel. So as we can see from our picture over here, we have two immiscible liquids which are being separated in the separation funnel, with the high density liquid being at the bottom and the low density liquid being at the top. And this is the valve of the separation funnel, which is used to open and close the separation funnel. So let's look at the extraction. So extraction is a purification technique in which compounds with different solubilities are separated using solvent of different polarities. And these techniques selectively dissolve one or more compound into an appropriate solvent. And the solution of the dissolved components is referred to as the extract. So now let's look at the test protocol, and we'll start by looking at the materials. First is the fresh leaves of spinach or Isera plant, mortar and pestle, calcium carbonate, acetone, petitar, separating funnel, 10% sodium chloride, sodium sulfate, and the extraction solvent. Now let's look at the test method for the extraction process. One is to obtain 5 fresh leaves of spinach or Isera plant. Next is to wash gently with tap water. Next, place wet leaves between 2 absorbent paper and blot dry. Next is to cut the leaves in pieces and place in a mortar containing a spatula full of calcium carbonate and grind, as shown in the picture over here. And what we have to note is that the role of the calcium carbonate here is to prevent the premature acidification and phytophytin formation during this assay. And I will encourage you to read on the premature acidification and the phytophytin formation. The next is to grind and add a solvent, which is a mixture of 22 ml of acetone and 3 ml of petitar, to obtain a green deep solution. And this solvent serves as the extraction solvent for the plant pigment, as it is non-polar and will dissolve in this polar solvent. So what it means is that our plant pigment is a non-polar pigment, and we need a non-polar solvent to allow this plant pigment, which is a non-polar, to be able to dissolve in it. The next is to decant the pigment extract into a separating funnel. Next, we add 20 ml of petitar and 20 ml of 10% aqueous sodium chloride. And what the sodium chloride does is that it creates a polar environment for any polar substance to dissolve in, and absorbs any water molecules that may be present in the organic solvent. And the petitar also creates a non-polar environment to allow the non-polar components of the plant extract to dissolve in. We then shake gently and allow the phases to separate. What you have to note is that the shaking is done to aid separation of the polar component in the aqueous sodium chloride and the non-polar component in the extract in the petitar. So after shaking, if we should allow our separation funnel to stand in our aerator stand for some few minutes, this is what we are going to see. And we are going to see two main layers, with the upper layer or the upper phase being the plant pigment and other nonpolar compounds that may be present, and the lower phase being our water and other polar compounds that may be present. So after that, we then drain lower layer into a beaker and discard. And if you want to do this, we will have to open the valve over here and drain the lower phase in a separating funnel as seen over here into a beaker. And if you also want to drain, what we have to note is that we have to remove the stopper, and this is the stopper of the separation funnel before draining. After that, we wash the upper phase 4 times with 5 ml distilled water, and this is to dissolve any other polar substance present in the pigment. So we drain the washed extract into an Erlenmeyer flask. So after adding the 5 ml of distilled water to it, and we allow it to stand, this is what we are going to see. So this is the plant pigment over here, and this is our water layer over here, or our polar solvent over here. So after draining, we will be left with only our plant extract that we are interested in a separating funnel seen over here. So after that, we drain the washed extract into an Erlenmeyer flask. So we will drain this into an Erlenmeyer flask, and we add about 4 spatulas full of sodium sulfate to remove excess water from the pigment phase after the pigment phase has been washed with distilled water. So what it means is that the role of the sodium sulfate over here is to remove excess water from our plant pigment. So after that, we filter the extract through a fluted filter paper into a measuring cylinder and record the volume as shown here. So now let us look at this question. So explain why petita and acetone were used for the extraction of the plant pigment. And the answer is the plant extract is a nonpolar compound consisting of different pigments with varying polarities. And hence acetone, which is a less nonpolar solvent, and petita, which is a more nonpolar solvent, are needed to be able to extract all these plant pigment with their varying polarity.